Apparently, thank you, Selena. I already passed out the chapter 6 homework assignment before in the past. I just couldn't remember if I copied it or not. So I went ahead and gave you another. So you probably have 2 of the same thing that say chapter 6, which is my bad. No, I haven't said any words. I ain't got to say any math words. I'm getting angry about it, but it's okay. Let's see. There was something I was going to say about that. Yes, okay. So you were given the new chapter 6 homework. We're reducing the assignment again. 4 per. So like there's, like this is a section. You need to pick 4 of those. This is a section. You need to pick 4 of those. You have to pick 4 per section. 4 per. When we take our next test. Which has to be at the latest next Thursday. Has to be at the latest. Hopefully we can make it happen before then. At the latest, it has to be next Thursday because, next Friday is your semester exam. Even if you're exempt from the semester exam, we're still doing it as a 60% grade. So either I'm going to type it into the 60% grade for you, or I'm going to type it in as your overall semester exam, depending on whether or not you are exempt or whatever that stuff is. I don't know. I can type it in both ways and we can see which one's going to impact your average for us. We would think so. But at the same time, it depends on what your other scores are at the 60.
Yeah, I guess it depends on what you score on that test and what your current
Yes.
is.
Yes. There are a lot of variables at stake, so it just depends. But theoretically in life, you would think the overall 10% would make the bigger impact. Yes. Yes, you have an answer.
I don't mean any harm by saying this.
You're allowed.
Okay. Mr. Furman, what he's doing for his exam is he's making it, and I'm not saying this is what you should do.
Okay.
And he's making it optional so you can take it and it won't hurt you at all. It won't really help. Like if it,
Okay. Thanks for the laugh. That was funny. Okay. Let's see.
I support a different solution. What if we don't have a semester exam, but instead we take a mock exam sometime second semester?
Oh, we're probably doing that second semester as well. We're probably doing all the things. This is me. We're doing all the things. I do all the things. Okay, we got to get started though, because you still got to learn chapter 6. So if you recall at the beginning of the school year, we discussed that our goal was to be through with chapter 6 by Christmas, and we haven't even said any words about chapter 6. So we've got to get rolling on chapter 6 pretty quickly. Now the good news is it's a lot. They don't call it necessarily a probability chapter, but it's still got a lot of probability stuff going on. So it's normally pretty understandable. Yes, dear. Okay. I'm not looking that up today. No. I don't bother to look that up. I'll look it up Friday for you. For me, it would still be 7th period on Friday anyway. I can look it up on Friday and give you options, and then those who don't have options, I'll be like, so sorry, I had to go into this because he was not. But regardless, you're stuck with me 7th period exam time on Friday anyway. Thank you, but Magical Bell scheduled for working that out for me. For once, having 7th period AP Stats worked out. Okay, so today we are, I heard the discrete comment. We've actually talked about these 2 kinds of variables before. We've got to talk about discrete and continuous and the difference between them. And the good news is, a lot of these formulas are also in your formula packet, but it would require you having that still and knowing when to use it. So I'm going to get my formula packet as well, because we are going to reference that in a second. Okay, so we are talking about a random variable. A random variable takes numerical values that describe the outcome of some chance process. The probability distribution of a random variable gives its possible values and their probabilities, which we've kind of hit at before, like a probability distribution with a 6-sided die. There's a 1 in 6 is a 1, a 1 in 6 is a 2, a 1 in 6 is a 3, that kind of thing. Now, if it was a weighted die, it might be more than likely to be a certain size, but anyway. There are 2 main types of random variables, discrete and continuous. If you've forgotten the difference between discrete and continuous, the main thing would be to remember that with discrete, have a countable number of outcomes. I'm not saying it's not a large number, excuse me, but we can still count it. So a discrete random variable, it takes a fixed set of possible values with gaps in between. So like if we're doing whole numbers, 1, 2, 3, 4, 5, that'd be an example of discrete variables. I get there's a lot of numbers that you know between 1 and 2, like 1.13, 1.35, but that's what they're saying, there are gaps in between. Okay, the probability distribution of a discrete random variable gives its possible values and their probabilities. The probability of any event is the sum of the probabilities for the values of the variable that make up the event. So, sum meaning we're going to add. That would be the key thing. We're going to end up adding in a second. So if you were looking at your formula sheet, so we're looking to decide, I can say words today, it's going to happen. If we're going to sum something up, there is a notation for that in math, which is the summation symbol. It looks kind of like a fancy E, it's Greek. Just anytime you see that, that's code for sum. Okay. Okay, that's nice. I'll give you a new one later.
That's nice.
Okay. What do you want me to say? Like.
I'm so sorry, dear. I'll put you out one immediately, for I am a good teacher.
I have like 50 in my bottom right drawer. Let me get through my notes and I'll find one.
Okay.
Okay. Steps for discrete random variables. Give your variable a name, i.e. x equals the number of children you plan to have. Set up a table listing all possible values of x. Sometimes this is done for you. Step 3. Write in the associated probabilities that are given in the problem. Sometimes this is done for you. And then step 4. As always in life, when we're dealing with probability, you know it needs to be between 0 and 1, and then if we're summing them all, they better not add up to over 1. Okay, so again, there are 4 steps, like give our variable a name, like possible number of children you plan to have. Give all the options, like I plan on having 1, I plan on having 2, I plan on having 3, and then however many you plan on having. And normally there's a set scale, like they'll tell you of how many they're wanting in the problem. And then step 3, normally it's kind of done for you, but you might actually be given some information. In the example we're about to work, it's done for us, thankfully. So write in the associated probabilities. Again, like if this was a die problem, it would be 1 in 6 for every side of the die. And then conditions, we want to check to make sure all our probabilities add up to 1 at the end. And then, of course, no probability should be like less than 0. Okay. In this example, or this illustration they're giving when they talk about the number of children, it is a discrete distribution, specifically because you can only have whole numbers of children. So you can't actually have 1.5 or 1.042. Like you actually either have 1 child or 2 children. Okay. So now you're like, I don't know what any of that means, so we're going to do an example practice. So, in 1952, Dr. Virginia Apgar suggested 5 criteria for measuring a baby's health at birth: skin color, heart rate, muscle tone, breathing, and response when stimulated. She developed a 0-1-2 scale to rate a newborn on each of the 5 criteria. A baby's Apgar score is the sum of the ratings on each of the 5 scales, which gives a whole number value from 0 to 10. So they told you whole number value 0 to 10, and then nicely, they actually wrote that in for you. So the x, which is the variable we're naming, that's really their score. So there's some scale that we're rating the children on. It's from 0 to 10. And so it's just their score on this rating scale. Okay, Apgar scores are still used today to evaluate the health of newborns. The table below gives the probability distribution for x equals Apgar score. So notice they already gave you the probabilities. Now, would it be smart of us to check to make sure those add up to 1 or really close to 1? Yes. And it's okay if it's like a 0.99 something. We realize there's a little rounding error in life. So the first thing I would do, because A says show that the probability distribution for x is legitimate, is I would add up all the probability distributions. So I would sum, so that's the sum symbol. I would add up all the p's. Meaning, and I know that notation looks fancy, but seriously, I'm just going to do 0.01 plus 0.06 and add them all up. But I didn't want to list it out, so this was a fancier, faster way to explain to the reader what I'm doing. Okay, so 0.001 plus 0.006 plus 0.007 plus 0.008 plus 0.001. Yep, we pray. Then it's not legit, is it? Absolutely not. Yeah, like it should add up to 1. And if it doesn't, then you would say, assuming a mistake was made because it's supposed to add up to 1, blah, 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 and keep rolling. Because never should you give up on part A and be like, oh, well, I couldn't do A, so B and C are out. Because you know that's not going to work in life. Okay, so I added them all up, and I did get 1. So I seriously typed them all in my calculator. And they did add up to 1. But, I mean, that made sense before we even talked about what we're doing today. All the probabilities should add up to 1 with all the options of it in a minute, of course. Okay, using your calculator, make a histogram of the probability distribution and describe what you see. How do we do this?
Plug in the data points.
Into where?
Yeah,
so let's go and 1 and, I know we hadn't gone off script, so let's go ahead and go 1 and 2 can have a point. I'm going to go to my list. I'm going to type stuff in on 1. Yes, so stat edit, and you get to edit your L1. So my L1 is going to be 0 through 10. This is a good review for life. So I typed in all my expected values, or all my X options in the L1. And I'm going to type in all my P of X's, so all my probabilities in the L2. Okay, so I have all mine typed in L1 and L2. I'll give you a second to type yours in. If you're done typing in, look back over those probabilities and think about what these APGAR scores are representing. Why is the score of a 9 at almost 44%?
Because they're measuring the health of the babies.
Right, so we assume most are
Healthy.
healthy, and why are they given a 9 and not a 10?
Because they must have gotten something lower than categories, 25 categories.
Which makes sense, because it seems non-surprising that nobody's perfect. I'd be hesitant to hand out a perfect 10 as well.
Yeah.
Okay, so now that we typed it all in our list, how do we make a histogram from here?
Oh, it's really history.
Because it says histogram. So I know I'm going to say a stat plot, but then what?
Go over the ones and then you select the type that has touching bars.
Okay, so I'm going to turn my plot on, in case you forgot that much. You got to turn it on. A histogram is the one with the bars touching, Hunter says.
Oh, I just had a terrible flashback. Like some serious PTSD.
And you should make a histogram of the probability distribution. So I didn't even need to type in L1. I just needed to type in L2. So L1 is where I typed all my expected, or my X values. I really said, if we read the problem, make a histogram of the probability distribution. Where did you type in your P of X's? I typed mine in L2. So I'm going to need to change that to L2. So second L2. But of course, other people have used my calculator, so I gotta adjust my life. I didn't even think about that before I pressed enter.
Whoa, dude.
Oh.
I like lines.
I like lines, but way too many. Seems like a very nice slope.
So anyone want to see Word or Express?
In Zoom, remember we're going to Zoom stat because we're in stat class.
Statutory.
And then it ends up looking really funky. Describe what you see.
I only see 3 bars.
I only see 3 bars, but you know that's not how we describe it. So describe what you see.
It is skewed.
It is
right.
skewed right.
I got a bunch of bars.
I didn't get that.
Did you press stat? Did you press Zoom and then stat block?
Mine just kind of shows it.
Oh, well, yeah, you do, yes. But ours are not fancy enough. We have to tell them Zoom stat.
Yes, I did.
Okay. Okay, so when you Zoom stacks, we still have to do that. Yes, Jackson? Yes, Zoom. We're going to say it's skewed right. Clearly that is not a, what's it called when it's the beautiful bell curve?
Symmetrious.
You wouldn't believe this, but the quiet table 3 said it first. You can have their point.
Unimetrical.
Wait. What is it?
Normal distribution was completely correct. But Jared, he slipped it out before anyone else did. He was all that, like whatever I see. Okay, so but ours is not normally distributed. Ours is clearly skewed right. And then they said part C, doctors decided that APGAR scores of 7 or higher indicate a healthy baby. What's the probability that a randomly selected baby is healthy? What is the probability that a randomly selected baby is not healthy?
Let's do some possibility.
Okay, so what should we add together then?
Just have like 9 and 10.
Yeah, let's add 7 through 10 together. Because that is a point. And we're going to call those the healthy. Okay, and am I actually going to bother to then add up 0 through 6?
No.
No. I'm going to do 1 minus the healthy in order to figure out the unhealthy.
It's 90%.
Did you get 90?
90.8.
So he added all these up and he got 0.098?
0.908.
0.908. Sorry, that's what I meant. That's not what came out though. So 1 minus 0.908. 0.092, which is kind of what we're hoping in life. About 9% are unhealthy, about 91% are healthy. So a randomly selected baby is healthy, 91% healthy,
Say 1%.
91% healthy. And then I can put 9% not healthy. And again, I'm rounding. I probably should put the 0.908 and the 0.092. But I have that on my paper as well. I have all the things. They can piece it together. Okay, are there any questions about this example? Oh, it's very good. And notice on the APGAR score, you can't get a 2.5 or a 3.2. Like you either get a 0, 1, 2. It's discrete scores. Okay, you're on to the next page. I'm telling you, chapter 6 is not bad. They try to make it look like it's really formula crazy, but it's really not bad. Okay, so the top of it says mean, expected value, variance, and standard deviation of a discrete variable. Good Lord. Okay, so mean, which is also called expected value. We've talked about in the past that you want to write mean as the mu of x, or for us, e with a capital X. We just talked about maybe when we have a problem, we're going to make that capital X, like on our last problem, it was the APGAR score. And the E of X means the expected value of that APGAR score. So like on our last problem, E7 would mean expected APGAR score of 7.
That's just on the last one. Like, I think
Yeah.
it's not gonna be a common thing.
No. Yeah, of course, Amy. Okay, and to actually calculate this, you want to summate. So if you wanted to, so that was just, my example was just a score of 7. You and I know our last thing was 0 through 10. So if we wanted to know, considering all the expected values for the entire event, why not do, so like the expected value of a 0 times the probability of getting a 0. The expected value of a 1 times the probability of getting a 1. The expected value of, a 3 on the score times the probability of that score. So what this formula is saying in English, because otherwise you're like, that looks like a hot mess, but it says, take each of the random variables, multiply that by its associated probability, and then sum them up to find the mean. Okay, and then Kenzie will get hers later, but for those of us who do have our formula sheets, if we look, so we last left off with probability, and they have the formulas like the union and the P of A given B. Right underneath that, I see the expected value, and we're about to get to the variance formula as well. So these formulas are in your, always in your hands. But again, it requires you to understand what the XI, what the PI means. So if you don't understand the formulas, having them in your hands isn't necessarily a good thing. Okay.
What does variance mean?
Say it again.
What does variance mean?
Variance.
That looks familiar.
Yeah, notice that variance looks just like standard deviation, but without square root.
Sure.
So literally, it's standard deviation without taking the square root.
It's sort of square root, so it's
That way they can make them all positive. That's why.
sure.
We've had this discussion before. Yeah, stay over here. Huh? Yes, but not right the second. Okay, so let's actually skip down and go ahead and answer the first part of the next problem. So sadly, Jackson's getting that. We're still in the APGAR one for now. It says,
I don't not like APGAR.
no, you're just wanting to know what the normal thing is. I agree.
The name that part is pretty sweet.
Calculate and interpret in context the mean of APGAR scores by hand. So again, we just found out that formula for the mean is E of X, which means we're going to add up all of our options times their probabilities. So for us, so X1 would be like the 0, and the probability of getting a 0 was, I have to flip back to my other paper to see.
0.00.
And then plus 1 times whatever its probability was.
Oh, this is
And then plus 2 times whatever its probability was.
I'll just look back at this.
And then plus 3 times whatever its probability was.
Probability being those things up in the boxes.
Yeah, the lower side of the box. So 0.00678. And so, yeah, you can see how listing this out would be tedious, hence why they normally just leave it in that notation. And honestly, in real life, would you actually take the time to list all this out on your paper? Probably not. Probably not. I would probably just put the formula and then literally calculate it by hand. So flipping back to the front page, I'm seriously going to do 0 times this plus 1 times that probability. And I'm just going to go straight down my table. Okay, so looking back at the front page, I'm just going to do this times this plus this times this and just keep on working my way down. So 0 times 0.001, which is dumb to put in, but I'm still going to do it anyway, plus 1 times 0.006, plus 2 times 0.007, plus 3 times 0.008, plus 4 times 0.012.
Is it gonna affect anything like so we don't need to do parentheses or anything?
I press enter every time, so I don't have to do parentheses. If you want to list them all out with parentheses, it's not going to hurt anything.
Really good to learn this first time in your head.
Yeah, absolutely. I'm just, if you're going to press them, might as well press them all, right?
Sure.
Once you start it and you're just like, oh yeah, I'm just typing the same thing over and over. 6 times plus 7 times 0.099 plus 8 times 0.319 plus 9 times 0.437 plus 10 times 0.053. I get 8.128 when I add them all up.
Yes.
Okay, are there any questions about how I did that math to get the 8.128 before we talk about what that 8.128 means? Get it later.
I heard a word almost come out.
Nah. Okay, so flip to the back. So we found that expected value in my calculator, and it was 8.128. Okay, but I'm supposed to calculate. We did calculate, but we still need to interpret this in context. So if we were to interpret this in context, what does it mean?
That's the mean, that's the estimated what they should get.
Yes. So on average, baby should score
The highest you can get is a 10, so it's a really healthy baby.
on average. A baby should score, and I'm going to put an 8 on the APGAR. Did they call it a score? On the APGAR scale. Okay, why did I put 8 instead of 8.128?
Because
Because
you
it's
can't get
like-
Yeah,
Three.
yeah. Can you actually score an 8.128? No, you can only score. You have to score an 8 or a 9, and so I'm going to round down to an 8. In fact, it probably would have taken a lot for me to want to round up to a 9.
Where would you want to run to a 9?
if it was
It was like 8.9 something.
Oh, yeah.
Okay, are there any questions about A? Okay, so we've calculated and interpreted the mean. Again, we've done mean and variance and stuff in previous chapters. Now we're just taking probability and applying it to this. So it's not that deep. Just darn them with their ugly looking formulas. So part B wants us to calculate the variance. So let's look at the top. There's a formula for variance. And it has expected values. And it looks like quite the formula. Thankfully, it is also in your notes and in your whatever. Flesh, Sally, you never point for that word. It's also in your formula sheet. Notice that we're doing, so our score, like our score of a 7, minus that expected value. When we just calculated the expected value, it's 8.128. So we're literally going to do 0 minus 8.128, 1 minus 8.128, 2 minus 8.128. That's what the x minus mu x squared means. And then times the probability of x. Well, the probability of a 7, if I look back on my other side of the sheet, the probability of a 7 was a 0.099. So I might be doing 7 minus 8.128 squared times 0.099. Now again, it's not that deep, but you can see how this is going to take forever to actually do by hand, because my gosh, that's just me doing the 7, expected score of the variance with 7s. And I've got to do the sum of them all. So I've got to do zeros all the way through 10s. Okay, and if we're reading it in words, take each of the random variables, subtract the mean, which is the expected value, square it, multiply it by that value's associated probability. Do that for each of the random variables and then sum. Okay, so on ours,
We should never
for
have
part
a
B.
negative number.
do what here?
We should never have a negative number, right?
Right. Well, yes, because we're squaring it the whole time, yes.
What if you just do the two variables have option and calculate? Is that not an option? Oh, okay, cool.
We're gonna eventually get to all the calculator buttons. For now, humor those who are going to actually, work their tail off and do it by hand. So xi minus mu of x squared times p of xi, you're like, I don't know what that means. It's really not that deep. So like our first score was potentially a 0. Our expected, which we just calculated in part A, was 8.128. You need to square that. And the probability of getting a 0 was 0.001.
Who in the world sat down and came up with this idea to do all this crap?
What is actually pretty genius to take what the expected minus what I actually got and then times the probability of me getting that actual score of a 0.
That's a challenge our math teacher.
Well, Miss Compton, why do you change the way you write your twos?
I don't know. Sometimes I randomly get
Like, right here, there's already, you've already
Yes.
That's
I
infuriating.
know. I can't decide which one I like. I like the curly one and then the straight one comes out for some reason.
The freaking straight one. Come on.
No, the straight one looks like a Z.
No, wait. No joke. There was a city in Michigan where they literally banned straight people. It was.
Yeah, hell, Michigan.
Yeah.
That's crazy. Okay, so, and then get back to your life and focus. 2 minus the expected squared times the probability of a 2. And we gotta keep on going. So our last one's gonna be 10 minus 8.128 squared times the probability of a 10, which was 0.053. So no one lies, yes, dear.
Never mind. I'll stop it.
Okay, no one disagrees that that's going to take some time to calculate. No one disagrees.
That is for damn sure.
But again, I am like Louise, take the thing that says by hand seriously. So I'm actually going to do this by hand, and it really doesn't take that long because you're just timing the same stuff over and over again. So 0 minus 8.128, and then I square it, and then I times it times 0.01. And so my first number is 0.66.
0.0.
Oh, I did that wrong. Thank you. You can have a point.
I really hope I don't.
Okay, so 0 minus.
Whoever's humming what you just saw.
It's Shalia. You're the one who's been humming.
You can throw hands at each other.
All around.
I don't take your money anyway.
Okay, it's faster to do it like that. Okay, thank you, Louise. You can have a point for that. Okay, so 0.066. Stop.
Oh my god. Please stop.
All points retracted. What?
The tapping. The tapping.
Tapping.
Ear aids. Please stop.
What is that? Oh, is it here?
Yes. Okay, so I did the 0. I'm doing the 1. I got 0.304. I don't care. I mean, I do care about you, but you're tapping into all my nerves too. So 0, 5. So I did the 0s. I did the 1s. Now I got to do the 2s, and I keep on going. I need help because I can't do this all day. I did 0s and 1s. Someone else do 2s.
That's a food.
It can't. How could it be negative?
Couldn't swear it.
Swearing everything.
Okay. The G is 0.21.
Okay. So on the 2s, I got 0.263. I need the 4s. So 4 minus 8.128. Square it. And then do that times, I don't know the probability of 4. 0.012. 0.204 plus, need to know the fives. You can have a point. You can have 2 points. You put me on 2 of them. 0, 1, 2, 3, 4, 5. I need 6, 7, 8, 9, 10. And Hunter is sort of correct. Yes, now that we're about to be like 7, 8, 9, 10. Once we get past 8 minus or 9 minus 8.12, it is going to be a positive number, but it's been positive the whole time anyway because we've been squaring it. So that's why we square it.
6 is 0.172.
Say it again, 0.172. You get no point for that. What about 7s?
Sevens are 0.125, 126.
Okay, I need 8s, 9s, and 10s. No.
Should it be a lower number?
Yes.
Sure. We got the 9s.
Oh, you have answers over there? She's a teacher, of course she has answers.
She's supposed to have hands. I'm gonna Google this entire one.
Alright, Louise, calm down.
Louise does that for every single one.
No, you're right, ma'am. And we'll talk about why in a second. What'd you say for 9, huh?
0.332.
Both of y'all can have a point of this one already, and I need 10, and then we can talk about why hers is so low.
So,
We'll do one.
wait, why is 9 so much higher than
10 is 0.186.
Okay, so let's talk about things. So we've got all these things, and I haven't added them up yet, because again, I still have to add all these numbers to actually figure out this variance. But let's talk about why some of the values are exactly what we predicted. Now, and Kinsey is asking exactly the right questions. Again, we're doing expected, our value minus the expected. Our value of 8 minus the expected of 8.128. It's a very small difference, right? And it was not that big of a probability, so we're not that surprised that 8 was such a small number. Now, the reason 9 is such a large number, I get 9 minus 8.128 wasn't that big, but since the probability was 0.4 something or other, which is almost 50%, no wonder it was such a large thing. Okay, we need to add all these up, and we'll have the answer.
2.06.
2.4 something.
Yeah, 2.06.
Sounds good. Okay, so they're saying the variance. So we're saying the variability between each of the things is about a score of a 2. So, you know, quite a few of our scores are between 6, because 6 is 2 below 8, and 10, because 10 is 2 above 8. So we're saying most of our scores are between 6 and 10. And don't we already know that's a true fact?
Yep.
Didn't we already calculate on the front side that was 91% of the babies? So we're not surprised. Okay, part C wants us to calculate the standard deviation. Thankfully, we don't have that much to do because that's what Louise was focused on. Notice between the variance and the standard deviation, there's very little difference between their formulas. Genuinely, the difference is we take the square root. So I need Hunter, who has it typed in his calculator, to take the square root of the 2.06 and tell me what he gets.
1.44.
So he took the square root of that variance. He found the standard deviation of 1.44. And then last but not least, it says calculate these measures using the one variable stats function in your calculator and compare it to the results that you found by hand. So, darn it, Louise, we're trying to take shortcuts in life. Maybe we could have done this all with our calculator to begin with instead of sitting there all day. So if we go to stats, calculate one variable stats. Again, I have my probabilities typed in list 2. I tell it to calculate. I see my expected value. I mean, you can't actually, so the average X bar. Did I do that right? Calculate these 3 measures. Using the one variable stats from your calculator and compare the results with what you found by hand. Oh. Why are there 11? Oh, because you're over here. And this is troublesome. Why is it troublesome? Okay, but the one variable stats, what were we calculating when we did one variable stats? Just one variable. And when you and I were calculating this, weren't we using 2 things?
Yeah.
So that's probably why Louise is assuming we need to use 2 variables. That's not a bad thought. So let's see, we wanted to use L1 and L2.
Even after I did that, I didn't find an answer that was like.
Yeah, and I still don't see what I want.
Yeah.
So again, actually calculating this, I know eventually we're going to learn some shortcuts, but it's really not that bad. Like, still not that deep. Could be integrating, could be differentiating. There was a lot of stuff in pre-cal that required a lot of time too, and even algebra 2 trig. Like we did a problem today with putting something in vertex form. It took like 3 years of my life. I can do this. It's just repetitive. I take my number minus my average, multiply it times the probability. Not that deep. Yeah, life. Okay. We can stop right there because I can't do normal distribution that fast. Not that good today.
I'm just gonna go home and I'm gonna consume my 2-pound bag of powder. Hopefully it's loaded each day so I don't give myself another ulcer and go through it out once again.
You could